Y'all, we are going to do some combinations of functions. Okay, so we have a sum of functions, which is f plus g of x, which means you take both of your functions and you add them together. Then we have our difference of functions, which is f minus g of x, where you take both of your functions and you subtract g of x from your f of x. Make sure you use parentheses. And then we have our product of functions where you multiply them together. Also, make sure you use parentheses. And then we have our quotient function where you will take your f of x divided by your g of x, and this is where our g of x does not equal 0. So you will actually figure out what the answer is and then also what their domain is. So our f of x is 2x minus 1, and our g of x is x squared plus x and a negative 2. So first, let's do our sum of functions. So we have our f plus g of x. So we have our 2x minus 1 plus our x squared plus x minus 2. Here, we're just going to add like terms. We have an x squared. We have 2x plus x. So 2 plus 1 is 3. Keep and keep. It's a positive 3. Then we have a negative 1 and a negative 2. Signs are the same, so you add and keep. And so this would be the sum of our functions. Okay, for the difference of functions, we have f minus g of x. So you have your f of x, and then in parentheses, I'm going to put my g of x. And the reason why I do that is because I'm actually going to distribute that 2. That 2. Why did I say 2? That negative through to everything on the right-hand side. Here, what we do is just combine like terms. I have a negative x squared. Then I have a 2x minus x. 2 minus 1 is just 1. Keep and keep. You would get a positive 1. And then I have a negative 1 plus 2. Signs are different. Subtract. Keep the sign of the larger. That would be our difference of functions. Now let's do our product of functions. What we have here, I have right here in notes. Make sure you use parentheses. Technically, it's similar to FOILing, but because our right-hand side is a trinomial, not a binomial, it wouldn't be called FOILing. We're going to multiply both of these together using distribution. What I mean by that is this 2x is going to multiply everything on the right-hand side. And what we get is 2x times x squared. 2 times 1 is 2. Keep and add. 2x times plus x. 2 times 1 is 2. Signs are the same, so it's positive. Keep and add. 2x times a negative 2. Well, 2 times 2 is 4. Signs are different, so it's negative. Keep your x. It didn't multiply to another x, so it's not going to change. Our exponent's not going to grow, but we do still have our variable in our product because it was in our original multiplication. And then we do our negative 1 times everything on the right-hand side. That negative 1 multiplying everything, you're going to still have x squared and x and 2, but that negative sign is going to change all the other signs. So what we get is a negative x squared, a negative x, and a positive 2. Here we combine like terms. There's nothing else with a exponent, S3. There's nothing else with an x cubed. Then if you do 2x squared minus x squared. So here we're combining like terms. So it's addition and subtraction. So you do 2 minus 1 is 2, right? Why did I say 2? Sorry, let me write that right here. 2x cubed minus x cubed. 2 minus that little invisible 1 is 1, and then our 2 is the largest, so it's a positive 1, and then you keep your variable, keep your exponent. So I get a positive x squared. Sorry for that mistake. And then here we have a negative 4x and a negative x. Those signs are the same, so you add them together, keep the sign, keep the variable, keep the exponent. Then we just have this little positive 2 right here. So the product of our functions is 2x cubed plus x squared negative 5x plus 2. Okay, now for our difference, quotient, what you do is you take our f over g, which is 2x minus 1 over x squared plus x minus 2. If you do the AC method on the denominator, what you get for your factors is an x plus 2 and an x negative 1. On our notes, next to the quotient function, it states that our g of x can't equal 0, and we need to be finding the domain for all of these, correct? So because it's in a fraction form, I know that I can't divide by 0. So I'm going to find the domain of all of these, working my way from quotient to product to difference to the sum. Okay, so this is the answer to finding the quotient of those two functions. But for our domain, what you do is you need to actually figure out when our denominator equals 0. And our denominator equals 0 when both of these factors is set equal to 0. Sorry about that. Here I would get a negative 2, and here I would get a 1. So this is telling me I know x cannot equal those, right? So I know that x cannot equal a negative 2, and it cannot equal 1. So whenever I do my domain, what I have is negative infinity to a negative 2, combine that with negative 2 to 1, and then we're going to actually combine or union that with 1 to a positive infinity. So this is the domain of our quotient function. Now, the domain of our product is all real numbers because it is a polynomial. The domain of our difference is all real numbers because it's a polynomial. And the domain of our sum is all real numbers because it's a polynomial. So, because polynomial, our domain is all real numbers. Polynomial. Okay, that is combination of functions using the algebra functions. Thanks, y'all. Bye.